Okay, now here we go. Let's look into the graphing now. First thing, what we want you to do is to factor this completely. You get the 3x minus 1 all over x plus 3 times x minus 3, because that's difference of two squares, and that's the fully factored form. So I'm just going to slip a arrow in right there. From that, we can tell what our vertical asymptotes are. None of the factors are reduced, so we don't have a removable discontinuity, or also known as a hole, so there's none. But we do have two vertical asymptotes, one at x plus 3, right there, for the value that x can't be in the function based on the factors of the denominator. And then we have x to equal -3 from that factor, so we get an asymptote at x equals -3. Now I'm going to graph those in there right now, just to as we go through here. Graph those two guys. Alright, now it's taken shape. So now let's look at the next one. Let's look at horizontal asymptotes. Right. As a reminder, when you're doing these problems, start at the factoring it, then looking at the asymptotes. Put those in the graph, then work on the rest of the graph from a table, and then work on the rest of the parts of the graph itself. Horizontal asymptotes, this one's bottom heavy. Because it's bottom heavy, as x goes to the extremes, positive infinity and negative infinity, the denominator of this fraction gets much larger, much faster than the numerator of this fraction, which means we're going to have a small number divided by a very large number. That's not how you spell small. That's funny. A small number divided by a very large number, which makes this whole fraction very close to the number 0. So we have a horizontal asymptote at y equals 0. I'm going to draw that in as well. That's what happens when it's bottom heavy. There aren't going to be any slant asymptotes, because in order to have a slant asymptote, it needs to be top heavy. So we're not going to have any. From there, I'm going to go ahead and do my table, an XY graph. When we do our table, we need 2 to the left, 3 in the middle, and 2 to the right, if we can. So I'm going to denote here that we have our asymptote at x equals -3 to kind of split up our table, x equals 3. And then I'm going to get that table, I'm going to go ahead and drop the function into my calculator. I'm going to put the original in, and I'm going to put the factored form in. What that's going to do is that's going to give me an opportunity to check. Oops, typed it in wrong. Going to give me an opportunity to check my factoring to see if I did it correct. So then I'm going to put the factored form in here. Okay, and then I'm going to check my table after that gets in there. This one. I'm going to check my table. It looks like to be the case that I factored it correctly and I typed both incorrectly in the graph correctly. So what we're going to turn around now, and we're going to use the second table set feature, make sure it's on ask, so that I can go to the actual table feature on the calculator and then type in the values I want to use. Now the values I want to use to the left, so I'm going to pick -4, -5, 3 in the middle, I'm going to pick 2, -2, 0, 2, and then I'm going to pick 4 and 5, just to kind of make it look a little pretty. I'm going to type in -4. Oops, so we're starting at -5, then -4, then -2, then 0, then 2, then 4, then 5. And those are going to give us our points. So at -5 we have -1, at -4 we have -0.86, at -2 we have 1.4, at 0 we have 0.11, at 2 we have -1, at 4 1.57, and at 5.88. I'm going to graph those points on our graph here. Okay, now make sure it matches what the graphing utility looks like. Make sure the graph grinds closer and closer to the asymptotes here at the ends. If you're not using the graphing utility, that's fine. You can still kind of get a really good picture of what it looks like just by taking a peek at what it is from the table. So now there we go. Let's answer some of the other questions as we progress. Factored form checked domain. Let's do domain. Goes to the left forever. So the domain goes from negative infinity and then splits at negative 3. Doesn't reach negative 3, and then union back to on the other side of negative 3. Then it goes to positive 3, union, positive 3, and then to the right forever. Domain, how far down, how far up? Now it goes down forever, that's for sure. There's an arrow facing down. It actually goes up forever, and it even hits 0 because it crosses the asymptote in the middle. So that winds up being our range. Now for our, let's do x-intercepts, we need to know that y equals 0 on this. So let's look at you can kind of look at the graph. Does it cross the x-axis anywhere? Yeah, it does. That ends up happening right there. To do that, we're going to set the whole function equal to 0. We're going to set y equal to 0 in the original function. So we get 0 equals 3x minus 1 over x squared minus 9. Now what happens on this is for a fraction to equal 0, the numerator of that fraction has to equal 0. And then we add 1. We get x is 1/3. So we get 1/3, 0. Now we only have one of them. As you can see, if we had to, there would have to be a max or a min represented there and have to kind of peak above or below the asymptote, kind of hop sides there. Let's do y-intercept, x equals 0. This one's the easy one, and in fact that's on our graph, so it's 0.11. Minimums, there are no relative minimums because there's no valleys, and maximums, there are no peaks. Looking into the last problem on this review guide, first we're going to factor. You get y equals, this one's going to factor as x minus 5, x plus 2 all over x minus 4. Now there's nothing that cancels, which will tell you that there aren't going to be any holes as well, so we can almost just go right there. That turns into our factored form. But this is top heavy, so we need to expect that there probably is a slant asymptote. We'll see that as we progress. Vertical asymptotes where the denominator equals 0, so we have 1 at x equals 4. I'm going to draw that in. Then horizontal asymptotes, this one's top heavy, so there is no horizontal asymptote, so we're going to write none. Slant asymptotes, the way we go about finding that is we divide it. Divide the numerator by the denominator, and we take the quotient and we throw out the remainder. So we get x squared minus 3x minus 10 is the original as the numerator of this function, and then the denominator is x minus 4, and we're going to divide those. We switch the sign, put it in the penalty box. We just take the coefficients there, drop it down, multiply, drop it down, multiply, and we're left with a negative 6. But then we convert that back into a function, which would be x plus 1, and that gives us our slant asymptote. Alright, from there, let's take a look at this. We have our asymptotes graph. Let's look at our table. To get our table again, we're going to notate that we have a vertical asymptote at x equals 4. We're going to type this into our calculator. I want to type in both into my calculator to verify that I factored it correctly. Takes a little while to type it in sometimes. Then we're going to check our table. Let's see how it goes in here. Am I getting an error message? Nope, we're good. It just hadn't updated. So that's the general look of what the graph is going to do, and I'm going to use this, the table feature in the calculator to get my answers. So to the left, which would be 3 and 2, sound fine. To the right, which would be 5 and 6. So I'm going to do 3, 2, 5, 6. 2 is at 6, 3 is at 10, 5 is at 0, and 6 is at 4. Let's go ahead and plot those points. Let's do 1, 2, 1, 2, 3, 4, 5, 6, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 5, 0, 6, 2, 3, 4. And then we have our slant asymptote at x plus 1 that I'm going to graph as well. To get a better picture, we got this other asymptote that's going to show up, x plus 1. And then when we connect our graph, it's got to grind closer and closer to the asymptotes to get the most accurate picture that we can. From there, let's talk about it. Now we're going to have two x-intercepts. You're going to have to realize that from the picture it crosses it twice. That's where y equals 0. So we're going to take into the original function, we're going to make y equal 0. If you remember, for that function to equal 0, the numerator of the function has to equal 0. So we're just going to set that up, and we are going to see if that factors. Hopefully it does. If not, well, it does. We already had factored it once. So we get two solutions, x is 5 and x is negative 2 for a y-intercept. So we get 5, 0, 1, 2, 3, 4, 5. That makes sense. And then we get negative 2, 0, 1, 2. And that visually kind of makes sense based on what we're looking at. There aren't going to be any maximums on this because there's no peaks and valleys. Again, no minimums. To get our y-intercept, we set x equal to 0. We don't have that in there, but I'm going to use my graphing utility to make it easier. I'm going to just put 0 in for x, and it's 2.5. 0, 2.5. Let's look at the domain. It goes to the left forever. Yep. It splits at x is 4. Union, and then we're back on the other side of 4 right away. Then it goes to the right forever. Great. Range goes down forever. Yep, there's no holes, so we don't have to pay attention to that. It goes up forever. Great. Anything left? Nope, we're done. And that's the end. Of course, you can email me if you have any questions on this at rshowalter@gmail or rshowalter@geneva304.org if you have any questions. Thanks, and have a good one.